PJ. This is demonstrating the LabVIEW embedded module for ARM microcontrollers. And what we're doing here is we're actually using LabVIEW to design a controller for an inverted pendulum. So what we have on the screen is a simulation of an inverted pendulum here and the controller for that pendulum. So you can see, hopefully, that this pendulum here is standing upright. When I nudge this, the pendulum can be moved around, so we'll nudge it again. There we go. You see the controller recover. Let's nudge it pretty hard. And I can nudge it hard enough that it actually falls over. Oh no. Oh, but it caught it. That's great. So what I can do here is I'm designing this on my PC with LabVIEW. What's new and why we're showing this in the ARM booth here at Embedded System Conference is that I can also run this on an ARM microcontroller or on, in this case, the microcontroller simulator on the desktop. So what I do is I just switch this control to the ARM simulator, and we see over on the left-hand side over here, this graph begins to update with the output of the ARM controller. So we're actually outputting now virtual signals from this virtual processor that's running on the PC here. So this ARM simulator is now balancing the pendulum, and it's this design and prototype and deployment of our embedded controller. It's me, PJ, again. We're here at Freescale's booth with Maureen, and Maureen's going to show us a demonstration with LabVIEW and Coldfire.
Okay, so we're showing today a demo with Coldfire, sensors, and Zigbee. What we've done is outfitted a golf club here. There's a small board, I don't know if you can see it from there, that we have a Coldfire core, a 3-axis accelerometer, and a Zigbee transceiver. And we also have a dual-axis gyro mounted on the shaft of the club. So what's happening is we're measuring all of the sensor data in real time, sending it wirelessly over Zigbee onto this LabVIEW interface. And so you can see, if you go ahead and move the club around, you can see the real-time data. And in parallel on the MCU on this board here, we're running a DSP algorithm to determine impact. So when you swing the club, you make impact with the ball, we can detect that. Once that occurs, we keep a buffer of a certain amount of time of this data. We can go back in time after it makes impact and determine what was the angle of the golf club when you actually hit the ball, so we can tell, did you hit it off to the right, to the left, did you hit it real high? And we can also estimate the approximate velocity when you strike the ball. So if you want to give it a shot, the only thing you need to know is there's a small calibration period. So if you hold the club just like that for just a moment and take a swing whenever you're ready, just a small swing, nothing over the head.
It's like really hard.
Just a chip.
Way out there.
No, this is we have a shot of about 8 meters, so that's what we're going for here. Oh, nice shot.
Oh!
I think that's the best shot we've seen all day. We sent that data also over Zigbee to this LabVIEW interface and then demonstrated the estimated ball flight.
Well, you guys heard it here, shot of the day. Awesome. Hey everybody, I'm PJ again. We're now here in the Luminary Micro booth at Embedded Systems Conference. So this is another demonstration of the LabVIEW embedded module for ARM microcontrollers. This time we're going to be programming this board right here that we've got dangling in front of our screen because it's so small and nimble. This is a Luminary Micro evaluation kit. You notice it's got this little nice LCD display. So it does, and it has buttons and lights and all that. So what we've got here is our LabVIEW code that's running now on this Luminary Micro. It's actually generating a sine wave here, and I hope that we can see that. Yeah, we can see that okay. So it's generating a sine wave and also reading the buttons. So when I press the left button, for example, the L becomes dimmer. Can you see that okay, Jamie? Great. And then also, I have this LabVIEW front panel where I'm able to control some of the components of the board. So for example, if I take down the amplitude of the sine wave, you notice that the amplitude goes down. This is connected to JTAG, via JTAG. So this is actually reading and writing memory directly on the processor. I can change the frequency as well as just turning on and off a basic status LED that's right there. Okay, everybody. Hi, it's me again, PJ. We're now on the road here at NXP's booth. NXP, founded by Philips. So NXP is one of our partners, an additional partner for the LabVIEW embedded module for ARM microcontrollers. We're actually running here on NXP silicon. This is called the MCB 2300. And what I'm going to do is this is actually running a web server. So you see Ethernet here is connected. And there we go. So Ethernet is connected here. So it's actually running a web server down on this board. And I'm going to control the blinking of these LEDs. So if in my web browser over here, I can check these inputs, update that, and we'll see that these LEDs start blinking on the board. If you can't see it, it's okay. Take my word for it. The LEDs are blinking. In addition, so this is our LabVIEW graphical code. We've got a front panel showing which LEDs we've chosen, actually reading the analog input of the board and displaying it on a web page so you can monitor your applications remotely.